everybody, my name is Okugulok Harrison, and today I'm going to be taking you guys on the concept of linear momentum. The physics of linear momentum is very simple, it's not difficult, it's not scary, okay? It's very easy. But in this content, we are only going to be dealing with the concept of linear momentum. We are not going to go into the problem solving associated with this concept. I'm trying to make sure that every one of us understand the concept first, okay? So linear momentum is very simple, it's not hard. I will do everything possible to break it down, okay? Now, when you're talking about linear momentum, you're talking of a body with its relative mass and its relative velocity moving along a straight line. So when a body of mass is moving along a straight line with its relative velocity, with the relative velocity causing that body to cover that displacement, that's what we call the linear momentum. So linear momentum has to do with a body moving along a straight path with its mass and its velocity. I get what I'm saying? So linear momentum has to do with a body of mass, okay, at this point moving along a straight line, okay, with its velocity. So the body started a motion with its initial velocity, and this is the final velocity. Okay. Now this body in motion, or this body at this particular point, cannot turn or cannot enter into motion without an agent acting upon it. So for a body at rest to be in motion, there must be an external agent acting upon it. A body on its own can't move. It can't change displacement. It can't cover a distance if not that a force is acting upon it. So the force in this content is that agent that causes a body at rest to be in motion, or a body in motion to return back to rest. That is what we call the agent of force. So force is an agent that causes a body to be in motion and in motion back to rest. So this body now at this initial point moves a distance because of the force that is exerted on the body. Okay, and now this is the distance covered. This is the body of mass moving along a straight line with its relative velocity. That is what we call the linear momentum. Now, momentum is of two types. We have the angular momentum and we have the linear momentum. But in this context, we are going to be dealing only about linear momentum. Angular momentum is a different topic on its own. Angular momentum has to do with a body moving around a circular path with its mass and its velocity. Okay? Now, we are now going into the law of inertia. Inertia is an inherent property of a body to remain at rest or in motion to continue to be in motion. Or like if a body is at rest, the body will be at rest. Or if a body is in motion, the body will continue to be in motion except a force is acted upon it. That is Newton's first law of motion, and that's what we call the law of inertia. So inertia is a measurement of mass. So the greater the mass of the body, the greater the inertia. And the lesser the mass of the body, the lesser the inertia of the body. So the inertia is a measurement of what? The mass of the body. But a body at rest that still remains at rest is due to the fact that the inertia of the body is stronger than the force. Okay? Now, when the body is now set into motion, that inherent tendency that tends to keep the body back in, or that tends to keep the body consistent in motion is what we call the inertia of the body. I guess what I'm saying. So for a body to be in motion, there must be a force exerted on the body. A body cannot just be in motion. Something prompts that body to be in motion. Something propelled that body to be in motion, and that is what we call the agent of force. So Newton's first law is what we call the law of inertia. The law of inertia is the measurement of the mass of the body. So inertia is the measurement of the mass of the body. And it is that inherent tendency that